Okay, so I have just created my notes. You can see here, and now I have to read this that what I have created from ChatGPT. Let's see here. So from here, I am going to read. So what is Arnan? So here, Arnan is like a think of an Arnan like a small kid listening a story. When someone tells a story, you listen to one sentence, you remember a little bit. Then you hear the next sentence. When someone tells a story, you listen to one sentence, you remember a little bit. Okay, you remember the little bit because when you are hearing the sentence, you can't remember the everything. So here also going same. So you listen to and one sentence, you remember a little bit. Then you hear the next sentence, and your brain uses the old memory plus new sentence to understand the story. Basically, you are using your memory and you are storing your previous sentence to understand the next sentence. You are just connecting to each other, then you are able to understand the story. So this is exactly how an RNN works. So and your brain uses the old memory plus new sentence to understand the story. Simple. RNN is a neural network that reads data step by step and remembers a little from the previous step. Okay, a little from the previous step. So what is RNN? RNN is a neural network that reads data step by step and remembers a little from the previous step. And where is RNN used? Text, sentence, music, time series, temperature, stock price, audio, anything that comes in sequence. Anything that comes in sequence, we use RNN. How does RNN thinks? Imagine you say number 5786. So RN things like that. For 5, it remembers 5, and when you read the another word 7, then it remembers 5 and 7. When you say the another word, another number 8, then it remembers 7 and 8. When you say 6, then it remembers 8 and 6. Okay, when you say 6, then it remembers 8 and 6. So but Aaron has a weak memory. It forgets all things quickly. Just like a small kid remembers one one the last one two lines of the story. Like when you are telling a story to a kid, okay, then if you have explained everything about the story, then maybe the children is not able to understand what you have told, that what you have told, like all the sentence. That the kid can't remember all the sentence. Okay, it can remember only little thing, and it will tell you. So this is actually Aryan is like a child, like it can't remember everything. So Aryan problem is what? Short memory forgets long sequence. So forget long sequences. Vanishing gradient problem becomes confused when learning long steps. Vanishing gradient become it has a vanishing gradient problem because becomes confused when learning long steps. Slow training cannot work on many steps together. It has a slow training cannot work on many steps together. In machine learning, a gradient tells the model. In machine learning, a gradient tells the model. In machine learning, a gradient tells the model how much and in which direction should I change my weights to reduce the error. Like we were studying in the machine learning that you have to go like this downward, then you will become the winner. Your gradient descent, you reach to the your gradient descent and your loss become uh, less. Okay, so big gradients, uh, sorry. So big gradients change weights a lot. A small gradient change weights a little. Zero gradient model stops learning. Okay, when you have a zero gradient means model stops learning, and small gradient change weights a little. So this is used in a back propagation, like you just start to calculate everything. Simple analogy: gradient means learning signal. It guides the model to move towards lower loss. Like when we move downward direction of the gradient descent. No gradient, no learning. Best gradient, fast learning. Big gradient, fast learning. Here we have a simple difference. Gradient is the slope of the loss. Gradient is the slope of the loss function that tells the model how to update its weight during training so that the error decrease. Great. Now it's connect to next concept. If gradient becomes too small, then it creates some vanishing gradient problem. Model stops learning. If gradient becomes too big, exploding gradient problem means training become unstable. If gradient flows normally, model learns well. Like Lstm explained, like you are a 5 year old. So, so if gradient flows normally, then model learns well. Now understand another concept which is Lstm. So Lstm like is think of Lstm as a kid with a notebook. Think of Lstm as a kid with a notebook. When someone tells a long story, the kid writes important things in the notebook. Okay, like we have some of the student who is talented and who think and who is smart, so they do not write all the sentence, they only keep the keywords. So the kid writes the important thing in the notebook. He crosses out useless thing, he removes useless thing, and he only put the important thing. He keeps what he needs, so he remembers even long stories perfectly. If he remembers keywords, then he can connect all the keywords and he can find the meaning of the story. So he remembers even long stories perfectly. This notebook cell state. Okay, LSTM simple definition we have a LSTM is an improved version. LSTM is an improved version of an that can remember things for a long time using gates. Uh, for a long time using gates. LSTM has three gates. For gate, should I erase this from my notebook? Input gate, what new things should I write in my notebook? Output gate, what should I say or use from my notebook? What should I say or use from my notebook? What should I say or use from my notebook? This is output gate. Where is LSTM used? Chatbots, text prediction, stock prediction, time series, language translation, speech recognition. Why is LSTM better than RNN? RNN is like a small kid with small memory. LSTM child with a notebook remembers more because it notes the important words. It solves vanishing gradients. It keeps a long term memory. Works better on long stories, means long sequences. Extra theory here we have a RNN learns using back propagation through time, like going back and checking every step. LSTM learns slower but remembers far better. LSTM learns slower but remembers far better. LSTM is older and stronger, while GRU is a faster but with less memory. While GRU is a faster but with less memory. What is cell state? Think of a cell state like a long-term memory line in LSTM. So cell state is a kind of a long-term memory. So it has a highway where information can travel from start to end of the sequence without getting lost. So it is a highway where information can travel from the start to end of the sequence without getting lost. So means cell state is a kind of a cell state is a kind of a long memory. Okay, it can remember more things. RN forgets old information. RN forget old information. LSTM cells state. LSTM cell state means LSTM has a long memory. Cell state means long memory. So LSTM cell state helps it remember important thing for a long time. Super simple example. Cell state, LSTM long term memory. It gives important information. It removes unimportant information. It helps the model remember thing for many steps. Imagine this: you have a school bag. You put important things like books in the bag. You remove useless papers. You carry the bag all day. This bag cell state. This bag is cell state. It carries important information through all steps. Cell state is an LSTM's long-term memory that flows through all time steps and helps the model remember important information for a long time. Full LSTM explanation here we have a LSTM has a three important thing, which is cell state, long-term memory, hidden state, short-term memory, gates, control, what to keep, what to forget, what to output. We will understand all three. Cell state, long-term memory. Think of it like a long highway where information travel, important thing can flow from the beginning to end. Remember, long-term info does not forget easily, helps solve anything written problem. Hidden state. We know hidden state means small memory that changes at every step. Small short memory. Hidden state is small memory that changes every step. Imagine cell state, big note. Hidden state, small sticky note. Sticky note carries the current important information to the next step. Sticky note carries the info, current, sticky note carries the current important information to the next step. Sticky note carries the current important information to the next step. Sticky note carries the important information to the next step. Okay, that's why it is a short term memory, because it only carries the short information. Okay, uh, cell state is what? Long term long memory, and hidden state is short memory, and both work together. Gates in LSTM. Gates in LSTM. Gates are like doors. They decide what goes in, what stays, and what goes out. LSTM has three gate. Forget gate. What should I forget? Example: Virat Kohli is a cricketer. He scored a century. We keep Virat Kohli is male, but we forget unimportant words like is is and a. So forget gets removes useless info from cell state. Input get, what new information should I add? If new important info comes, it gets stored in cell state. You read Virat Kohli means Kohli plays cricket. You store Kohli plays cricket. So what's output get means what should I so as output right now from cell state plus hidden state. Output is generated. Next word example, next word prediction, sentiment, etc. What information moves inside LSTM? What information moves inside LSTM? Let's imagine a sentence. Virat Kohli plays a cricket. Input comes in word Virat. LSTM asks, should I store something? Should I forget something? Forget gets checks old info. If something is not needed, throw it away. Step 3. Input get adds a new useful info. Virat person mail gets added to the cell state. Cell state carries the stored info. Cell state carries the information like a long river flowing through all steps. Now it remembers Virat means male and Virat is cricketer. Hidden state keeps short info, and state stores what is important right now. How to output gets produces the final output. Output gets produces the final output. Output gets produces the final output depending on the task. Next word classification, prediction, summary. LSTM part easy meaning. Example: cell state, long term memory remembers Virat male. Hidden state, short term memory remembers current word meaning. Forget get removes useless info. Remove is and like is and a. Input get add new info. Add like Virat is a player. Output get output next word prediction. So here we have a small definition. LSTM stores information using cell state. LSTM stores information using cell state, long term memory, and hidden state, short term memory. It has a three gate: forget gate, input gate, output. Control the flow of information to prevent the forgetting important information and solve the vanishing gradient problem. So this is our LSTM and RNN. So now move on to the uh, another post. Okay. Where is So here we have a code of LSTM, code basic for understanding. Import numpy MP number and arrays handle करने के लिए for numpy we use for mathematical calculation from tensorflow.carry.model import sequential model को step by step बनाने के लिए From the simple dot create dot layers import Lstm dense Lstm layer plus dense output layer, and then we have a training data x equals to then 1 2 3 sequence 1 sequence 2 हर सीक्वेंस का नेक्स्ट आउटपुट, हर सीक्वेंस का नेक्स्ट आउटपुट 1 2 3 का 4 2 3 4 का 5 3 4 5 6 का 6 वी हैव अ 6 एंड एलएसटीएम को क्या चाहिए व्हाट एलएसटीएम नीड इट्स नीड अ सैंपल टाइम स्पेस टाइम स्टेप्स एंड फीचर सैंपल्स कितने सीक्वेंस यहाँ यहाँ तीन कितने यहाँ सैंपल मीन्स व्हाट कितने सीक्वेंसेस मीन्स 3 सीक्वेंसेस वी हैव ओके टाइम स्टेप्स इज व्हाट हर सीक्वेंस की कितनी की लेंथ यहाँ तीन सो इन एवरी here you can see in every list we have a three particle so three particle three elements so we have a what we have a time step हर sequence की length मतलब तीन so particle inside the list is time steps फीचर मीन्स हर टाइम स्टेप में कितनी वैल्यू हर टाइम स्टेप्स में कितनी वैल्यू एक है ओके सिर्फ एक नंबर की 1 2 3 तो कॉमा के अंदर मतलब कॉमा के बाद कॉमा के अंदर एक ही वैल्यू है तो फीचर मतलब एक ही नंबर रिसीव करते वक्त हम तीन चीज़ें स्पेसिफाई कर रहे हैं थ्री सैम्पल थ्री टाइम से वन फीचर पर टाइम स्टैम्प सो हियर वी आर रिसेपिंग यू कैन सी एक्सट्रॉट सेप देन एक्सट्रॉट सेप एंड वन यहाँ save dot 3 means sample yeah save dot means sample and then in the one index we have a 2 3 4 means it is a what it is a time steps I think yeah it is a time step then in the third we have a one okay so model building model sequential model start then model dot add lstm 50 layer memory unit activation relu memory unit 50 neuron activation rule smooth learning input shape 3 1 time stamp 3 feature 1 time shape in input shape and then model dot add dense 1 एक ही नंबर प्रिंट करेगा model dot compile adam gradient descent adam smart learning method minus coordinator measure number के gap का score okay then we have model fit epoch purpose पढ़ो को 200 बार डेटा सिखा रहा prediction टेस्ट डॉट नब्बे डॉट एरे रिसेप सीक्वेंस को भी थ्री बनाना पड़ेगा ज़रूरी है थ्री सैम्पल मॉडल प्रोडक्ट बताएगा 4 5 6 आएगा ये इंपॉर्टेंट तुम्हें बोला कि 24 होता है तो फीचर क्या होगा 24 होगा तो क्या हो जाएगा हमारे दो फीचर हो जाएंगे ये हो गया एक फीचर ये हो गया दो फीचर ये हो गया तीन फीचर एक फीचर इसको एक फीचर इसको दो फीचर टाइम स्टेप में डेटा फीचर हर टाइम स्टेप में कितनी वैल्यू होती हैं अगर 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 हर टाइम स्टेप पर 24 नंबर होते हैं तब फीचर हो जाएगा 24 ओके यहाँ 1 यहाँ 2 यहाँ 3 ओके got it then move on to the another then we have a GRU GRU is a gated recurrent unit GRU is a gated recurrent unit it is like an LSTM but simple explanation GRU remembers the important things okay GRU forgets useless things GRU remembers important things GRU forgets useless things GRU updates its memory quickly GRU has only two gates update gate means Z gate should I keep old memory or take new memory should I keep old memory or take a new memory keep or replace reset gate R gate ask like that should I forget old information or old memory before using new input should I forget old memory should I forget old memory before using new input so it will reset old memory and it will get the new it will store the new memory because it will get all the it will store new information and at first it will see that which one is good which one is important for the data which important what is important okay so then we have a should I forget then forget or use an easy example imagine your brain is reading a story update when your brain is reading a story update get should I remember this line reset get should I forget previous line Jaru does this at each time step GRU versus LSTM. LSTM GRU. 3 gates, 2 gates. More complex, simpler. Three gates has a LSTM and 2 gates has a GRU. More complex. The LSTM is more complex and GRU is simpler. LSTM is slow and GRU fast. More parameters, less parameters. LSTM has more parameters. GRU has less parameters. GRU is simple code. TensorFlow.Kera.1 import sequence. TensorFlow.layer import GRU. Then model sequential. GRU has 22 layers in return sequence. Return sequence false. Input shape. Then one model data. Dense one optimizer. Adam. Then 10 times step. 10 time steps. Okay. One feature 10 time steps. Okay, I got it. And one feature units means 332 memory cell and 32 memory cells. Return sequence means false. Only final output. Only final output. Okay, I got this. Now I have to move on another topic. LSTM versus. Then here we have some basic mathematics between LSTM and here we have some mathematics. LSTM long short term memory. LSTM control what to keep, what to forget, and what new info to add using its notation. We have a x t input at time t, st hidden state at t, and when cell state sigmoid. Tana is the activation function. Tan h is the activation function. Forget get has a sigmoid, and here we have something like that equation. T minus 1 and xt means input at t and input at t, then hidden state we have a okay, and we have a these kinds of parameters. Input forget get has a this equation, input get has a this equation, candidate memory then tan h, and then this equation update cell state, this equation output get has a this equation hidden state. Okay, then we have another LSTM manage information using 4 gates. 4 gates. The forget get decide what part of the old cell store to remove. The forget get decide what part of the old cell state to remove. The input gate controls how much new info will be added into the cell state. A candidate memory is created using TANH. A candidate memory is created using TANH and combined with the input gate to update the new cell state, and combined with the input gate to update new cell state, and combined with the new input with the input gate to update new cell. Finally, the output gets decides what part of the cell state becomes hidden state for the next step. Sigmoid gives value between 0 and 1 so that LSTM can keep order of information, and 10H creates a new memory signal. Candidate memory is the new information proposal. Cell state is a long-term memory. Hidden state is a short-term memory. Candidate memory is a new information proposal. Okay, then here it has only two gates: the update gate and the reset gate. Update gate controls how much the old hidden state should be kept. The reset gate controls how much of the old memory should be forgotten when creating new information. A candidate hidden state is created using the reset gate, which decide how much past information to include. Then update gate mixes the old hidden state with the new candidate state. If the update gate is close to 1, 0 keeps the old information. If it is close to 0, it replaces with a new information. Sigmoid in the gate gives a value between 0 and 1, and tan h creates the new candidate memory. This allows 0 to learn long term long term pattern with fewer parameters than LSTM. Okay, what is a bidirectional LSTM? Simple example. Bidirectional means the model reads the sentence from left to right and right to left. It understands both past and future words, so it becomes smarter than normal LSTM. Why do we need bidirectional? Normal LSTM only sees past words. Example, I want to eat a hot normal Lstm don't know the future word pizza. I want to eat a hot pizza. So normal Lstm don't know future word, but bad direction Lstm reads both the in the both way. It uses two techniques like reading from left and from right. Bad direction reads the sentence from both side, left and right, left to right, right to left. So it note I want to eat a hot pizza because I am hungry. Model becomes double smart. Think like this. If you read a sentence only forward, you miss future context. If you read a sentence only forward, you miss future context. If you read the sentence forward and backward, you understand the full meaning. This is exactly what bidirectional LSTM does. Okay, a structure. Bidirectional has a one forward LSTM, one backward LSTM. Then it joins both output, gives final answer. Here is bidirectional use sentence sentiments analysis, name, entity recognition, text classification, chatbot translation, speech processing. Then bad action LSTM reads input in both direction, forward and backward. It captures past and future context, make it better for NLP task. Tiny example code from disabled.care.1 import sequence from disabled.care import bad action LSTM then import sequence to bad action LSTM has a 20 to 30 layers 10 10 time step and one input add evidence one getting one was it now Adam okay got it. Then another we have another LSTM GRU वर्ष बैड डायरेक्शनल LSTM GRU प्रोजेक्ट में कहाँ काम आते हैं LSTM GRU और ये सब कहाँ काम आते हैं नॉर्मल LSTM GRU तब काम आता है जब मॉडल को सिर्फ 5 इन्फॉर्मेशन चाहिए होती है नॉर्मल LSTM GRU तब काम आता है नॉर्मल LSTM GRU तब काम आता है जब मॉडल को सिर्फ 5 इन्फॉर्मेशन चाहिए होती है तब काम आता है जब मॉडल को सिर्फ 5 इन्फॉर्मेशन चाहिए होती है अगले 5 दिनों का स्टॉक प्राइस प्रिडिक्शन अगले 5 दिनों का स्टॉक प्राइस प्रिडिक्शन करना है तो हम यूज़ करेंगे LSTM और GRU अगले शब्द की प्रिडिक्शन नेक्स्ट वर्ड प्रिडिक्शन टेम्परेचर प्रिडिक्शन टाइम सीरीज फॉरकास्टिंग मॉडल को सिर्फ 5 इन्फॉर्मेशन चाहिए होती है इन प्रॉब्लम में फ्यूचर कॉन्टेक्स्ट अवेलेबल ही नहीं होता इन प्रॉब्लम में फ्यूचर कॉन्टेक्स्ट अवेलेबल ही नहीं होता चीज़ें टाइम के साथ आगे बढ़ती हैं पीछे नहीं होती यहाँ बैड एक्शन बेकार है यहाँ नॉर्मल LSTM GRU परफेक्ट है बैड डायरेक्शन LSTM GRU तब काम आता है जब मॉडल को पास्ट प्लस फ्यूचर दोनों कॉन्स्टेंट चाहिए एप्पल इज़ लुकिंग टू हायर न्यू इंजीनियर्स अगर वर्ड एप्पल है तो आपका मॉडल क्या सोचेगा फॉरवर्ड पढ़ने पर एप्पल फ्रूट क्या है बैकवर्ड पढ़ने पर हायर न्यू इंजीनियर्स आप समझ आया कि एप्पल कंपनी इसलिए NLP में बैड डायरेक्शन यूज होता है बैड डायरेक्शन कहाँ उपयोग होता है प्रोजेक्ट में सेंटीमेंट एनालिसिस सेंटेंस को पूरी तरह समझना पड़ता है फेक न्यूज डिटेक्शन फ्यूचर वर्ड्स की मीनिंग बदल देता है स्पैम डिटेक्शन स्टार्ट प्लस इन दोनों इंपॉर्टेंट होते हैं नेम एंटिटी रिकॉग्निशन राहुल वर्क एट गूगल इन मुंबई एंटिटीज़ फ्यूचर वर्ड्स से क्लियर होती है टेक्स्ट क्लासिफिकेशन रिव्यू कमेंट ट्यूट आदि पूरी तरह समझने की ज़रूरत चैटबॉट इंटेंट क्लासिफिकेशन पूरा मैसेज पढ़ना ज़रूरी है इन सब में बैड डायरेक्शन LSTM जरूर बेस्ट है if the task needs full understanding of sentence meaning we use bad direction LSTM GRU if the task needs only past information like forecasting we use normal LSTM and GRU अब direct answer to your question LSTM GRU project stock prediction weather prediction heart beat EGC pattern prediction next word next value prediction it's a project of the LSTM bad directional is what bad directional LSTM and GRU project sentiment analysis spam detection, fake news detection, near document classification, chatbot, intent classification. Okay, got it. Then we have a batch normalization. न्यूरल नेटवर्क ट्रेनिंग में हर लेयर का आउटपुट कभी कभी बहुत बड़ा हो जाता है कभी बहुत छोटा इससे ट्रेनिंग स्लो हो जाती है न्यूरल नेटवर्क ट्रेनिंग में हर लेयर का आउटपुट कभी बहुत बड़ा हो जाता है कभी बहुत छोटा हो जाता है इससे ट्रेनिंग स्लो हो जाती है न्यूरल नेटवर्क में ट्रेनिंग में हर लेयर का आउटपुट मीन्स इन द न्यूरल नेटवर्क sometime layer gives the output small and sometime layer gives the output small and big. Okay, so because of this our training becomes slow. So पैच नॉर्म हर लेयर के आउटपुट को नॉर्मलाइज करता है ताकि वैल्यू स्टेबल रहे, लाइक नॉर्मलाइजिंग द वैल्यू बिटवीन 0 and 1, लाइक मशीन ओनली अंडरस्टैंड 0 and 1. So training fast plus accurate. Why use training fast created stable overfitting हम बैच नॉर्म लेयर एक्टिवेशंस को नॉर्मलाइज करके ट्रेनिंग को स्टेबल और फास्ट बनाते हैं. बैच नॉर्म लेयर एक्टिवेशन को लेयर बैच नॉर्म बेसिकली नॉर्मलाइज द लेयर एक्टिवेशन for training stable and for fast training. Famous CNN architecture easy linear stables. पहले प्रैक्टिकल CNN सबसे पहले प्रैक्टिकल CNN एंड डिजिट्स के लिए वेरी फास्ट 5 पेयर यूज सिंपल इमेज. एलेक्स नेट डीप लर्निंग को फेमस बनाना GPU यूज़ करके ट्रेन किया. फर्स्ट टाइम रेलू एक्टिवेशन पॉपुलर किया. 8 लेयर्स यूज बिग इमेजिनेट्स इमेज. VGG 19 सेम 3x3 कन्वोल्यूशनल को स्टैक करके डीप नेटवर्क बनाया. सिंपल प्लस पावरफुल, बहुत पैरामीटर, स्लो बट एक्यूरेट. ट्रांसफ़र लर्निंग में सबसे फेमस, बहुत इंपॉर्टेंट, RS नेट. डीप नेटवर्क ट्रेन नहीं हो पाते थे वेरिएसिंग ग्रेडियंट में. मीन्स डीप नेटवर्क ट्रेन नहीं हो पाते थे मीन्स इट्स अ वेरिएसिंग ग्रेडियंट. RS ने स्किप कनेक्शन रेसिडुअल ब्लॉक्स इंट्रोड्यूस किया. स्किप कनेक्शन रेसिडुअल ब्लॉक स्किप किया. मीन्स डीप नेटवर्क ट्रेन नहीं हो पाते थे वेरिएसिंग ग्रेडियंट. तो RN ने स्किप कनेक्शन रेसिडुअल ब्लॉक इंट्रोड्यूस किया. सिंपल आइडिया. नेटवर्क जो कहते हैं, जो इनपुट था अगर फीचर नहीं सीख पाया तो इनपुट को एक ही शॉर्टकट से आउटपुट में भेज दो. जो इनपुट था अगर फीचर नहीं सीख पाया तो इनपुट को एक ही शॉर्टकट से आउटपुट में भेज दो. इससे नेटवर्क 10, 101, 152 लेयर ट्रेन हो जाते हैं. वेरी एक्यूरेट मॉडल. ये इंटरव्यू में जरूरी पूछते हैं. आरएसएन मीन्स बहुत इंपॉर्टेंट. डीप नेटवर्क ट्रेन नहीं हो पाते थे मीन्स इट प्रॉब्लम. आरएसएन ने इसके कनेक्शन शेड्यूल ब्लॉक इंट्रोड्यूस किया. नेटवर्क को कहते ये सिंपल आइडिया है कि नेटवर्क कहते हैं जो इनपुट था, if the input is not able to understand the feature, then if input is not able to understand the feature, तो इनपुट को then you can use the input and इनपुट को एक ही शॉर्टकट से आउटपुट में भेज दो. थ्रू द शॉर्टकट you can send into the output. Okay, then 50 clear. Then another we have a ResNet. ResNet means residual नेटवर्क ईजिएस्ट एक्सप्लेनेशन. प्रॉब्लम क्या है? डीप लर्निंग में जब लोग 20-30 लेयर से ज़्यादा डीप सीनर बनाते थे, ट्रेनिंग स्लो हो जाती थी, एक्यूरेसी गिर जाती थी, क्रिएटिव वैनिश हो जाती थी, मॉडल वॉश हो जाता था, मोर लेयर नहीं बेटर होता था. इसे इशू डिग्रेडेशन प्रॉब्लम बोलते थे. इस इशू को डिग्रेडेशन प्रॉब्लम बोलते थे क्योंकि बहुत लोग यूज़ करते थे 30-20 लेयर्स. तो उससे डीप लर्निंग में ज़्यादा डीप CNN बनाते थे. तो इससे क्या होता था? ट्रेनिंग स्लो हो जाती थी, एक्यूरेसी गिर जाती थी, वैनिशी हो जाती थी. इसको डिग्रेडेशन प्रॉब्लम बोलते हैं. तो इसके लिए सॉल्यूशन क्या है? स्किप कनेक्शन, शॉर्टकट पाथ. रेस्टनेट बोलता है अगर नेक्स्ट लेयर कुछ यूजफुल नहीं सीख रही तो प्रीवियस लेयर का आउटपुट शॉर्टकट्स से आगे भेज दो. अगर नेक्स्ट लेयर कुछ यूजफुल नहीं सीख रही तो प्रीवियस लेयर अगर नेक्स्ट लेयर कुछ यूजफुल नहीं सीख पा रही तो प्रीवियस लेयर का आउटपुट शॉर्टकट से आगे भेज दो. मतलब नेटवर्क को फ्रीडम. कुछ नहीं सीखना हो स्किप, सीखना हो नॉर्मल लेयर. इससे मॉडल्स 50 लेयर इजीली ट्रेन हो जाते थे. सीखना हो नॉर्मल लेयर. आर ब्लॉक में इनपुट कॉन्वोल्यूट BN रेलू कॉन्वोल्यूट BN आउटपुट. आउटपुट फीचर आउटपुट fx प्लस fx लेयर का न्यू फीचर x शॉर्टकट है इनपुट। यही है रेसिडुअल लर्निंग। ये रेसनेट डीप मॉडल को ट्रेन बनाने के लिए सॉफ्टवेयर कनेक्शन ऐड करता है। रेसनेट डीप मॉडल को ट्रेनेबल बनाने के लिए शॉर्टकट कनेक्शन ऐड करता है। ब्लॉक न्यू फीचर एफेक्ट्स सीखता है। ब्लॉक न्यू फीचर एफेक्ट्स सीखता है एंड ओल्ड फीचर एक्स शॉर्टकट से ऐड हो जाते हैं। इससे ग्रेडियंट फ्लो स्मूथ होता है, वैनिसिंग ग्रेडियंट कम होती है और ट्रेनिंग इजी हो जाती है। डिस्टेंट मैथ लेयर को फीचर लर्न करते हैं। इनपुट इनपुट फैक्टर एक्स लेयर जो फीचर लर्न करती है एफएक्स लेयर जो फीचर लर्न करती है एफएक्स। इनपुट फैक्टर एक्स लेयर जो फीचर लर्न करती है। फाइनल आउटपुट वाई इक्वल्स टू एफएक्स प्लस एक्स। बस एक सिंपल एडिशन। इस एडिशन से ग्रेडियंट डायरेक्टली शॉर्टकट से पीछे तक मूव करता है। बैक प्रोसेस में क्या होता है? डेरिवेशन बिकम्स dy by dx dfx dfx by dx dy by dx and then plus वन that plus वन from the skip connection। gradient कभी जीरो नहीं होता, वाइनसिंग gradient सॉल्व हो जाती है। बाय सो पावरफुल वेरी डीप नेटवर्क ट्रेन हो जाते हैं लाइक 100 प्लस लेयर, बेटर एक्यूरेसी, फास्ट कन्वर्जन, नो gradient प्रॉब्लम, नो इंडस्ट्री स्टैंडर्ड फेस रिकग्निशन, almost everywhere। ResNet introduce residual block with skip connection. These connection adds the information. These connection add the input text directly to the output, giving y equals to x. This ensure gradient flow remains strong, solve finishing gradient, and allow training of very deep network. ResNet introduce residual blocks with skip connection. These connection add input text directly to the output effects, giving y equals to x. This ensure gradient flow remaining strong. Okay, then another